Okay, so I'm just going to take a few minutes to go over three really important theorems in calculus. And I'm not going to go into why they all work and the proofs behind them and all that good stuff, because that could take me a couple of hours. Instead, I'm just going to hit on, the nuts and bolts. What are they? How do we use them? So I'm going to start with the fundamental theorem of calculus, which is probably the most famous, and it's one that a lot of people learn very quickly once they've started talking anti-differentiation. And pretty much, you already know this theorem, you just didn't know it had a name. So it's what a definite integral looks like. If you see a definite integral, it's that whole idea of, oh, okay, there's bounds, so I get to take the antiderivative of f and evaluate it at b. I get to take the antiderivative of f and evaluate it at a, and then I subtract those two values. So that is the fundamental theorem of calculus. And you've probably been using it. We're not even going to do an example here. I just wanted to let you know that is what it's called. Now for the next one, this one, it's fun to prove, but like I said, I'm not going to go into that right now. But the second fundamental theorem of calculus is awesome, and it goes with this whole idea of, what happens when you take the derivative of an antiderivative, okay? And that's kind of a weird... There's going to be all kinds of different variables here that throws people initially, but once we do an example, hopefully it'll make sense. So what this is saying is I'm taking the derivative of an antiderivative of a function, and we're going to let a be just a number, okay? A is just a constant. X is going to be x. It's going to be a variable. And what happens is, as you might suspect, a derivative and its antiderivative end up canceling each other out and just leave behind f of x, which is kind of awesome. Now, it gets a little more complicated if your bounds are a little more complicated. But if it's in this most basic form of a constant and an x, this is what happens. So let me show you an example, then we will step it up with a harder example. So for instance, if you are asked to take the derivative of the antiderivative of t cubed minus the square root of t plus the sine of t dt. Okay, so all that's going to happen here is, according to this rule, is you're going to ignore the lower bound because it's just a constant, and the upper bound of x is going to get plugged into your function. So the final answer on something like this truly is x to the third minus the square root of, x plus the sine of x. And that's it. Like, this is your answer. And it's kind of awesome. So you don't actually have to take an antiderivative. You don't actually have to take a derivative. This is what's going to happen. Now, what happens if I gave you the same problem, but it's a little funkier? So in other words, I'll leave that 3 down there, but let me call this an x squared, okay? All right. So if this were to happen, you still go about it the same way, but a chain rule gets introduced. And don't make it harder than it is. You're not going to chain rule these terms. You're just going to chain rule what you're plugging in. So in other words, just ask yourself, okay, well, since I'm not plugging in just an x, what is the derivative of a 2x? I'm sorry, of an x squared? And the answer of that would, of course, be 2x. So you look at that derivative, and that's going to be just multiplied by whatever happens when you plug this in. So x squared gets plugged into t, so if it's x squared to the third, it's really x to the sixth, minus what happens when I do the square root of x squared. Well, it's just an x, and then plus the sine of x squared. So I'm still plugging this in for all of the t values. The only difference is after you plug that in, or before, make sure you multiply by the derivative of whatever you just plugged in. Okay, one more in case it gets even a little more complicated than that. Let's do that x squared on top, but now let me change the bottom bound to an x as well. And what's going to happen here? T cubed, blah, 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 blah. Okay, what happens here is you end up combining the two theorems. So it's like I'm going to do a second fundamental theorem of calculus, but I also need to remember the first fundamental theorem of calculus, which says that, you know, if these aren't constants, if they're both variables, I need to do this sort of f of b minus f of a kind of concept in my head. And what that means is that we start with the top and we're going to plug it in. But remember, what's the derivative of x squared? Well, it's a 2x. So I'm just recopying that solution that I had above because I've already done this work. Okay, so we're going to plug in the top bound and evaluate it, minus plug in the bottom bound and evaluate it. Well, the derivative of x is just 1, so I don't have to worry about a chain rule, and then I just plug that in. X to the third minus the square root of x plus the sine of x. That is going to be my answer. As ugly as it is, that really is the answer. Yay! Okay, and so the last theorem that I want to talk about is the average value theorem. Okay, the average value theorem. Okay, average value theorem is, you know, anytime you're asked to find an average value of a function. Sometimes I also think of it as like an average height, but that's another story. But the average value theorem, you will directly be asked to find an average value, and the formula is it starts out as 1 over b minus a, but then beyond that, it's the same thing as the first fundamental theorem of calculus. So this part is going to be what you already know to do, but you just have this added component of, notice this is your averaging going on, like an average height, like you're looking at your bounds, and hopefully this makes sense, but f of b minus f of a. So, I mean, I won't even, I mean, I guess I could do an example of this. It would pretty much just be somebody saying, hey, you know, what is the value, or what is the average value for the function f of x equals, let's say, x squared minus x plus 1 over the interval 0 to 4 or something like that. So if you're asked for an average value and you have this, you're going to do exactly what this theorem says. I'm going to do 1 over 4 minus 0, because of course these are your a and your b. So 1 over 4 minus 0, I'm going to put my 0 here, my 4 here, and I'm going to solve. So this is going to be 1/4 out front, and the interval, I'm sorry, not the interval, the integral of this is going to be 1/3 x to the third minus 1/2 x squared plus x. We're going to evaluate that from 4 to 0, and once I do this math, I will be done. So if you want me to finish it, just because I may as well. That 1/4 is still out front. Plug in the 4. Awesome. And then minus, we're going to plug in the 0 everywhere. Now, if you notice, once you plug in that 0 everywhere, it looks like all of those are going to go to 0. And once you get a number for this, that would be your answer. I absolutely don't want to waste any more time on this video just doing arithmetic. So there you go. There's your answer once you figure it out. All right. Hopefully that helped with those 3 popular theorems.